All right, so with this video, we're going to get into a little more detail about how to use the command line. So we're going to talk about how to edit from the command line, the purpose and the role of the shell and the shell interpreter. We'll talk about doing some searches from the command line, using wildcard pipes and redirection from the command line. Also permissions and permissions of files, how to manipulate that from the command line, and also how to get remote access to the command line for both interactive commands and for also transferring files. So in terms of editing, there are lots of different text editors you can choose from Linux, and a lot of different ones that you can use on the command line. VI is the one that I'm going to talk about here. It's one classic utility. It's been around since 1976. It was based on what was called the visual mode of an early text editor on Unix. So that's where the VI comes from in terms of the name. And a lot of times you'll see it replaced now by VIM or VI improved, which is just a version of VI that has a lot more features in terms of editing with plugins, for instance, for some additional capabilities. So there you have a lot of different ones to choose from. You don't necessarily need to use VI for your editing, but I do suggest that you get at least some level of familiarity with VI. And the main reason for that is really because, in my experience, it's the one that you can count on always being there. So the example I gave before of maybe you've got a full environment that normally would boot up on your embedded system, but for whatever reason, you're getting stuck at a boot prompt and you aren't able to load the full system yet. Most likely, VI will be an editor that's available in that scenario. It might be that other editors are not available. And so having a little bit of knowledge of VI will let you use the command line for editing in that type of scenario. So in terms of opening a file with VI, you can just use VI plus the name of the file, or VIM in the case you're using VI improved. And then once you're into VI and interacting, you can use what's called normal mode for commands. So if you hit the escape key, you'll be in a mode that allows you to use the keyboard instead of for typing text, for typing commands to the editor. And so one of the things you would do inside the editor is navigate around inside the document. So you can use the H, J, K, and L keys to move left, down, up, or right within the file. And this might seem a little strange at first, but once you get used to it, it's pretty powerful because you don't have to lift your keys off, or your fingers off the keys in order to move around in the file. So you can go into and out of editing mode very quickly, and you can also move around in the file pretty quickly once you get the hang of using it. Then when you're ready to manipulate text, you can use I to go into insert mode and type text. You can also use the delete key or the D option to delete text. And when you're ready to exit and save a file, you hit escape to make sure you're in normal mode for commands. And then you can use :W to write the file and :Q to quit. So again, there's a lot more you can do with VI, and there are other editors out there. I encourage you to look through the links here, and if you're not familiar with VI, get a little bit of familiarity with it and some level of comfort so that you'll be able to use it when needed. So we've talked about interacting with the command line via the terminal, but we haven't talked much about how those commands actually get executed. So it turns out what's happening when you're interacting with the terminal is there's what's called a shell interpreter that's interpreting what you're entering on the command line, passing that off to the appropriate application for execution, and returning the results back to you on the terminal. And so in addition to the interactive use that we've showed in the previous videos and the current video, there'll also be the option to put a list of commands in a text file and pass that off as a script. And the shell interpreter will be the same thing that's going to be executing every one of those commands out of the script for you. There are lots of different shell interpreters out there, and a lot of them have very similar command support. The Bourne shell was one of the original shell interpreters, and that's often, you'll find that abbreviated SH. It was released back in 1979. Then there was K shell and C shell and several other shell interpreters that were developed. And each of those interpreters had some unique features in terms of options for commands that you could use with the shell and inside your shell script. And so what happened was the Bourne Again shell, or Bash shell, was created as a way to group all these useful features together from different shell interpreters and add some extensions to the original Bourne shell that was the 1979 version. So for most of the stuff that we talk about in this class, we'll talk about either using the Bourne shell, sh, or the Bourne again shell, which we'll call bash. So a few more useful things that you can do from the command line, and getting into some more advanced things that you can do from the command line. There's the find utility that will let you locate files or directories based on things like the file name or the type of the file. So here's an example of a command that will find any file or directory that's named a directory under the given directory that we're in. And so find dot means look under, the dot in this case means the current directory that we're in. Find dot means look for any file with or directory with name a directory under the current directory. And so what you see spit out if you run that command would be a list of all the directories under the current directory that are named a directory. And so because we did our copy from a directory to a copy target in the previous video, we'll find two matches of that here when we search for file by file name. Another thing you will find useful in terms of using the command line would be searching inside the content of the files for specific content. So if I have two different files, text file and text file 2, I use the cat option to concatenate out and look at the content of the files. I can see one of them says AESD awesome is awesome. The second one says CU is awesome. So if I do a grep command and I specify is awesome, it's going to find both of those, a match in both of those files. It's going to spit out those file names and the corresponding matching lines. And in this case, I even get some color syntax highlighting to show me which part of the string matched the corresponding text in these files. So one thing that you'll notice about the grep command that I specified, so I used the asterisk here as a parameter to the grep command. And what this, the asterisk in this case is a wildcard. So the star is telling the shell that any character in any name, in a name of a file in this directory should be passed into the grep command. And so if I just say star, what it's saying is that list any files in this directory and include that as one of the parameters to the grep command. I could have gotten more specific with this. I could have said text file star text, which would have meant any file that started with the name text file and ended with text. But by just specifying the star, it means match any files in that directory. So in the case that you specify a wildcard on the command line, what the shell's going to do is figure out what are all the different matches for that particular wildcard, and then pass that string into the ultimate command. And so the grep command, in this case, is going to get passed a string that looks like this. It's going to see grep-r is awesome, and then instead of seeing the star, it's going to see the expanded copy from the shell, and so it's going to see a list of all the different files that matched. And in this case, since I specified the star, it would pick any of the files that are in that current directory. So if I had text file 1, 2, 3, 4, it would list all of those on the output of the grep command and pass all of those in as parameters. So in addition to wildcards, one other useful tool that we can use on command line are pipes. So the pipe character is a character that will send the output of one command to the input of another command. And this is really useful. You see this used a lot in Linux shell scripting because it's very versatile. You can keep your applications tailored to do one specific thing. And when you're ready to combine the features of two different applications, you can just use the output of one fed into the input of another command and pass that to a third executable if you want to. So it allows us to chain commands together based on standard input, standard output. So the same kind of thing that you'd use if you're writing an application and using printf for standard output, you could be passing that as input to a new command using the pipe character. So if I use the concatenate command and cat out my text file.txt, normally that would print the entire content of text file.txt out to the terminal. If I use the pipe option and send it to grep, then that's going to pass the text file.txt as the input to the grep command. So before we were specifying we wanted the grep to read specific files, and in this case grep is just going to read what we passed into it from standard out, which comes from the concatenation of text file.txt. So you can see if I do cat textfile.text pipe grep is awesome, I will get the same output that I would get if I grepped the textfile.text file, and I get the match on the is awesome characters. So in addition to wildcards and redirection, or in addition to wildcards and pipes, there's also redirection that's really useful that we can use on the terminal. And so redirection is going to say, take an output stream, so for instance standard out in this case, what you would normally print out to the terminal with a printf command, and instead direct that to somewhere else. So one really common place that you direct this to would be to a file. So using the example of a grep command, so our grep is awesome, where we're looking for matches from any files in the directory to this string. If we use the redirect character and redirect to our search result.text file, what we'll see is that what normally would have been printed out on the terminal is now going to be inside this search result.text file. So if I cat search result.text, I'll see the content matching what would have been printed out on the terminal from my grep command. Similarly to redirection, we can also append. It's just using two of these redirect symbols, one right after the other. So if I say echo hello into that same search result.text file, and then I cat out the contents of search result.text, I'll see that I've added hello to the end of the file. Whereas if I would just use one redirect symbol here, I would have overwritten the content of the search result.text file, and you wouldn't see these initial lines here anymore. So the file permissions that control how we can access and use specific files, there's a common way of handling this in Linux systems, and there's really three levels of permission for user, group, and either world or everyone. So permissions are broken up based on who is the user of the file, typically the person who has created the file. What is the group account that's associated with the person that created the file? And then what are the permissions for anyone on the user, someone that's not the user that created the file or in a group that's the main group for the user that created the file. ls is the command that we used before to show the files in a directory, and you can use ls-l to show details about permission info. So in this case, if I'm looking at a list of files and directories that I've got in a directory on my system, I can see these characters rwx, r-x. What this is telling me is whether each of the user or group or everyone has read, write, or execute permissions on the directory or the file. And so the R means read, the W means write, and the X means execute. So you can see who the user is here from this first column that shows that the user is my user account, Dan. And by default, the group for your user would also be the same group account based on your username. So both of these this means that the person, the username Dan has read, write, execute permissions on the directory, and anyone in group Dan has read and execute permissions on the directory, which is the same as any user on the system would have read and execute permissions on the directory. So one thing that you notice is when I just create a file, so in this case, like for my text files here, I don't have execute permissions by default. And this is to avoid a scenario where you would be able to execute and have execute permissions on a file where you maybe didn't intend to contain script instructions. So if you create a hello world example script file that just has a single echo command that echoes hello world, if we do an ls-l on that file, you'll notice that there's no executable permissions set by default. If I try to run that command with this / syntax that says execute this hello world.sh script in the current directory, I'll get a permission denied message complaining that I don't have the execute permissions. So you can use chmod to change the mode of the file, and if I do u+x, this means for the user account, add execute permissions and give it the file name. If I do an ls-l, I can see a couple things. One is that the color syntax changed, so I see that it's green now, showing me that I have executable permissions. And I see this X bit set here in the user section of the permissions. So now when I run the command, I'll get the hello world output that I would expect. So the permissions in addition to specifying with something like u plus x or some strings that you can see detailed in the man page for chmod, you can also use octal digits in numeric mode. And so if you add some combination of 4, 2, and 1 together, you'll get a setting for read, write, and execute for those 3 different permission groups that we talked about already, the user, group, and everyone. So if I do an ls-l on hello world and I see that I have read, write, execute plus read and read permissions, if I do a chmod 766, what the 7 is going to make the user account have read, write, and execute permissions, because 4 plus 2 plus 1 is 7. The 6 and the 6 are going to mean set read and write permissions for the group and everyone. And so if I issue the chmod 766 hello world.sh and then I check my permissions with ls-l, I'll see that I get the permissions I expect here with read, write, execute for user and read and write for group and everyone. All right, so a really useful thing that you can do with Linux command line operation that we'll use for embedded systems very often is you can use what's called secure shell to get remote access. And you can use remote access for both interactively entering commands to be run from the command line, and you can also use it for transferring files with what's called SCP. If you're using a virtual machine here, you can set this up pretty easily with port forwarding rules, and there's a link here that tells you how to do this. But what you're basically setting here is the IP address that you'll be able to reach it from in your host machine, and the port that will redirect to port 22, which is the typical port used for SSH on Linux systems. So if I'm from my Windows system, I'll be able to access the command line terminal if I use SSH-P, giving it the port option and specifying 2222, which is my host port here. Then I can specify my username and at this IP address, which is the one we enter here for our host IP. So this is an example for VirtualBox. If you have a physical Linux machine that you're using, you just replace it. If you had a port redirect, you'd replace that here, or you just remove the port if you're using the standard SSH port. And you'd use the user account for the system plus the IP address or the host name of the system you're connecting. Okay, so if you are using a Windows environment for remote access to the command shell and you want to use SSH, there are several different options. 2 of them that I'll go over here. One is you can install Windows Subsystem for Linux. This is available on newer versions of Windows like Windows 10. You could also use MSys, and either one of these environments will provide you access to SSH that you could use from a Windows machine. So if you want to transfer from a Windows machine to your virtual machine, you can use the SCP command with a capital P port option to specify the port. You can specify the source directory here from the Windows machine and the target, both username and IP address, with this :tilde syntax, meaning copy to the home directory. The colon separates the machine information from the directory, and the tilde says copy to the home directory for the user. So if I do that and then I SSH into the virtual machine, what I'll see is that if I do it ls-la, that some file that I transferred in is going to be there in my home directory. Similarly, I could transfer out from my virtual machine into the Windows system with this SCP-P option, and then just swapping the order of source and destination as arguments to SCP. So this would transfer from my home directory, a sumfile.txt file, to my downloads directory on Windows in from vm.txt. So you can use these same instructions and SSH and SCP to transfer to and from Linux systems as well.